Okay, this is the second video, and I'm going to ask you to actually stop this video. I know it's kind of a strange way to start a video is by stopping it, but I'd like you to stop this video and see if you can answer those 4 questions. I really want you to stop the video and go try, and then come back and we'll talk about them together. Okay, I hope you actually tried. Let's look at all of the places where the particle is moving away from the starting position. So I can see that if we know the starting position is here at 0, and here at 0, and here at 0. So anytime we're moving away from the starting position, let's look at those places. So I can see that at point A, we're moving away from the starting position. The distance is getting further. We know we're moving away. Also at D, we're also moving away from the starting position. We're just moving in the other direction. At B, we have, so I'm going to answer 1 and 2 together. Does the object ever turn around? Yes, we know the object turns around. Well, I'm going to use a different color. The object turns around at point B because we have a 0 slope. In other words, the distance was greater, and then the object turned around, and then the distance started to decrease. Okay, the same thing here. We've got that the distance is increasing. We have a 0 slope, so the object turned around, and then we're getting closer to the starting point again. So let's talk about where we're moving away and how do we know. There are a couple things we need to look at. So we know that we're moving away at point A and at point D. And how do we know that? We know that for point A, first of all, the position is positive. So we're moving, let's just say, to the right. And the slope is positive as well. So I know that I am moving away from the starting position. So I know that the position is positive and the slope or the velocity is positive. Okay, for part D, we're moving away, but we're moving away in the other direction. So not only is the position negative, but the velocity or the slope is negative as well. Those are the 2 places where that particle is moving away from the starting position. A little bit tricky. Does the object turn around? Yes. And those were at 2 different places. So we knew that was at B and at E. And there are 2 ways we can talk about that, at B and at E. At B, because we know that we can say it 2 ways. We can say the slope is equal to 0 and changed from positive to negative. So that's how we knew for sure it turned around. And then at point E, the slope is equal to 0 and changed from negative to positive. Okay, part 3 says describe the velocity of the object at each point. Now draw the velocity graph. So at point A, positive velocity. We've kind of talked about this already. B is a 0 velocity. C, the velocity is negative. Talking about velocity, remember. We're talking about slopes. So we're talking about tangent lines at all of these. What are the tangent lines doing? What is the rate of change doing? That's what velocity is measuring. At D, we also have a negative slope. E is 0, and F and G are both negative. Okay, so if we draw the velocity graph, let's do that. All right, it starts out with a positive slope, then a 0 slope. So we're going to have to get a 0 slope here at B. So we have a positive slope to start. B is not the x-axis. I'm going to take that away. We have a positive slope to start, and then we hit a 0 slope right here. So that's about right here is at a 0 slope. From there, the slope is negative for quite a while, but look what happens. It's negative and not very steep. It gets really steep here. And then as we get closer to E, the slope gets not quite so steep. So negative, not very steep, gets steep, not so steep again, until we hit E, and then we have a 0 slope. Slope is not very steep, and then gets steeper and steeper and steeper. So the numbers get larger and larger and larger. Supposed to be a parabola. I didn't quite draw my graph that well, and that kind of makes sense because this was a cubic function, a third degree. So we know that the derivative, since that's the velocity, the derivative should be a quadratic. Okay, looking at the acceleration graph, let's change colors. Let's look at the slopes. So the slopes are negative and pretty steep. And as we reach this point, they become less steep until we hit 0. Then the slopes change to become positive slopes and get steeper and steeper. So if we draw this acceleration graph, I'm going to try and line it up a little bit better this time. So here's where the 0 slope is. Here's where the 0 slope on the acceleration graph is. We started out with negative slopes and then turned to positive slopes, and they get steeper and steeper. We knew that was a quadratic. This is linear. So this is acceleration. This is the second derivative. The velocity was this graph. The first derivative.